So here is a elective mathematics paper. You are welcome to this tutorial. Let's begin with question 9 under the pure mathematics section. A linear series AP is giving us 6 whole number 1 over 2 plus 9 whole number 3 over 4 plus 13 whole number 1 over 4. How many terms of the series must be added to obtain 707 whole number 1 over 7? So the sum of the series is 707 whole number 1 over 4. So we make use of the sum of term formula for the linear series, which is given by S sub n is equal to n over 2, 2a plus n minus 1d, where a is the first term in the sequence, which is 6 whole number 1 over 4. So we substitute those values. We don't know the n, that is what we are looking for, but the sum of term is giving us the 717 whole number 1 over 4. Then the difference is the d. The difference is the d, which can be found using any two consecutive terms. So this and this will give us the d. So we need to expand this to obtain this over here. We rewrite this in a standard quadratic equation form to obtain this equation here. We can simplify further to obtain 7n squared plus 18n minus 2869 equals 0. So we need to factorize this. So looking at the product of A and C, we get this, which will give us negative 133 and 151. So that will help us to split the middle term. And finally, we obtain our factors and then the values of n to be 19. Since we are talking about number of terms, we are going for n equal 19. And we discard this one. So there are 19 terms, and so far we have 1, 2, 3. So we have 16 more terms that must be added. Now the I part says that using the result in I, so this is our I, find the last term of the series. So there are 19 terms, so the last term is the 19th term. So that will be given by A plus 18D, which is 6.25 plus 18 times 3.5, which is 69 whole number 1 over 4. So that is the 19th term, which is the last term of the series. The B part of this question, the lines px minus y minus 3 equals 0 and 3x plus y plus 1 minus plus 1 equals 0 intersect at 45 degrees. We are to find the value of p. So we need to recall coordinate geometry 1, angle between 2 points, 2 straight lines. That's acute angle between 2 straight lines. So the first line is px minus y minus 3 equals 0. So we can rewrite this in the slope intercept form. So the slope is p. That means our first gradient is p. Our first slope is p. Similarly, our second slope will be negative 3. So using the formula tan theta equal absolute value of m2 minus m1 all over 1 plus m1 m2, we obtain this expression for p. Tan 45 we know is equal to 1. So we have an absolute value equation that we need to solve. So for this to be equal to 1, the expression here to be equal to 1, either the expression is negative or positive. Let's say negative 1, absolute value equal 1, then negative positive 1 absolute value is also equal to 1. So either the expression inside here is negative or positive. So if it is positive, we still get 1. If it's negative, we still get 1. So that will give us these values, these two equations that when we solve, we will obtain p equal negative half or p equal 2. So there are two possible values of p. All of them, when you substitute p inside this equation here and you plot the graph, you see that the angle between them, the acute angle between them is 45 degrees. So it should have been S here. Now we proceed to the next question. The functions f and g are defined by f such that x maps onto 3x plus 5 and g is such that x maps onto x minus 11 where x is a real number. We have to find g circle f inverse. So this is on relations and functions. So G circle F, composition of functions, it means G will operate on the result of F. So G of f of x, we substitute f of x, which is 3x plus 5, into x minus 11. So wherever you see x here, you put 3x plus 5. So that is what we've got here, minus 11. So this will give us 3x minus 6. So we are going to use the property, the identity, which says that when you compose a function and its inverse, so this function and its inverse, we should get x. So this is our g circle f of x, or g circle f. So it means g circle f inverse, this one, will now become an input for g circle f. So we will replace the x here by g circle f inverse. So wherever we see x, we put that, and minus 6. That should give us x. So we solve for g circle f inverse to get x over 3 plus 2. So this is the g circle f inverse. That is the A part for question 10. Now let's look at the B part for question 10. Using the trapezium rule with 5 ordinates, find correct 2 decimal places. The approximate value of the integral of limits, lower limit 1, upper limit 3, then the function is 3 over x plus 2 dx. So we recall the trapezium rule. The trapezium rule uses a trapezium to approximate the area under the curve. So we have this here. Okay, so we have this here, and we can see the trapezium, and you can see the function here that is sketched there. Some part of the function between 1 and 3. And we can see the trapezium or the trapezia that's also used to approximate this area. So we need to use 5 ordinates. 5 ordinates means the y values here are 5. 1, 2, 3, 4, 5. Good. So if there are 5 ordinates, then there are 4 trapezia. 5 ordinates will form 4 trapezia. So now the trapezium is a sum. It's a sum of these y ordinates, then half times the width of the trapezia. So either from here to here, or from here to here, or from here to here. So to find that width, you can take the upper limit, which is 3, minus the lower limit over the number of ordinates minus 1, or over the number of trapezia, which is 4. So the number of trapezia is 4, that is 5 minus 1, or that is number of ordinates minus 1, which is, so the width of the trapezia will be 2 over 4, which is 1 over 5, 1 over 2, or 0.2, 0.5. So when we take the lower limit, which is 1, we keep adding 0.5 until we get to the upper limit, which is 3. Then we plug in those x values into the function, which is this function. That will give us the y values here, 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 and here. And then we find the area. So when we do that, we can see this. The y value for x equal 1 is 1. So you can see in the graph, and 1.5 is this 0.857 up to 0.6 for x equal 3 over here. Now, we now use the trapezium rule, which says that the area under the curve f of x is given by integral of lower limit a to upper limit b dx equal half of the width of the trapezium into brackets. You add the first ordinate, which is this one, to the last ordinate, which is this one. Then all the other ordinates, you multiply them by 2 and add them. So this is the formula you can see here in your screen, on your screen. So when we substitute those values, we get what you're seeing here. And when we simplify, we get 1.5369, which is 1.54 to 2 decimal places as the question required. If alpha and beta are the roots of the equation 3x squared minus 5x minus 1 is equal to 0, find the equation whose roots are alpha minus 1 over beta and beta minus 1 over alpha. So we're given this equation 3x squared minus 5x minus 1 equals 0. So alpha plus beta is minus b over a, which is 5 over 3. Then alpha beta will be c over a, which is negative 1 over 3. So this is the c over the a, this is the b over the a. Now, the new equation, we need to find the sum of the roots. So sum of new roots will be this plus this, which is giving us this expression here. Now, we need to use arithmetic to simplify this to obtain this, as you can see on the screen. So we need to substitute. So upon substitution, we obtain this expression here. And now we need to simplify this to get 20 over 3. So our sum of roots for the new equation is 20 over 3. The product of roots is also obtained in a similar manner. First, we multiply this and this to get alpha beta. This and this will give us alpha beta. And this will give us minus 1. And this will also give us minus 1, which will give us negative 2 there. Minus 2 there. Then this and this will give us plus 1 over alpha beta. So we know alpha beta is negative 1 over 3. And we also see the negative 2 from this simplification. And this will give us negative 16 over 3. So the equation is given by x squared minus sum of new roots, which is 20 over 3, x plus product of new roots, which is negative 16 over 3 equals 0. So when you multiply through by 3, you get this equation. The B part says we need to find the value of alpha beta into bracket 1 over alpha squared plus 1 over beta squared. So what we are going to do is to simplify this first. So alpha beta into 1 over alpha squared plus 1 over beta squared will give us this expression here. So we know alpha squared plus beta squared is equal to alpha plus beta squared minus 2 alpha beta over alpha beta all squared using the law of indices. So this can take care of this, one of these, and we are left with this. So we substitute to obtain this expression here. And when we simplify this expression, we will get this, which eventually give us negative 31 over 3 or negative 10 whole number 1 over 3. Here is question number 3. But before that, please, if you have not yet subscribed to this channel, please do that for me, and also share this video with your mates so that they will also benefit from it. And don't forget to click the like button. If 2x minus 1, x plus 2 are factors of f of x equal px cubed plus x squared minus qx plus 2, find the values of p and q. So if these are factors, then they are factors. Then if these and these are factors of this polynomial, then we will set each factor to 0 and plug them into the function. And they must also give us 0. So for 2x minus 1, we have f of half to be equal to 0, since that is a factor. So we put half everywhere we see p, everywhere we see x in this function, and that will give us this result, as we can see. And when we simplify this, we get 1 over 8p plus 1 over 4 minus half q plus 2 equal 0. Now we create a fraction to obtain equation 1. P minus 4q equal negative 18. We repeat a similar process for x plus 2, and this will also give us the equation negative 8p plus 2q minus 6. But I want to eliminate the q. So since this is negative 4 here, I'll multiply this by 2, and for that matter, the whole equation by 2. And that will give us this equation, as you can see. So by adding the two equations, we eliminate q, and we have negative 15p equal negative 30. And that will give us p to be 2. Now let's come to we substitute p equal 2 inside of equation 1. So and that will give us this equation, as you can see. So we now solve for q to get q equal 5. We are to differentiate from first principle, y equal 3x minus 1 over 2x. So this can be given by the formula limit as h approaches 0 of f of x plus h minus f of x all over h. So this is our f of x, which is 3x minus 1 over 2x. We plug that into this formula to obtain this. So f of x plus h, wherever we see x in a function, we put x plus h. And that will give us this first result here. Then minus f of x, which is this second result, all over h. So the rest is algebra. The rest is algebra. Forgive me for repeating this here. So we need to expand the first one over here to obtain 3x plus 3h. And by doing that, then 3x will cancel the negative 3x here, and that will give us 0. So we are left with this expression here. So we need to collect LCM in the numerator. So the LCM for the numerator will be 4xh into bracket x plus h. So that will give us this expression here. When we collect the LCM, we get this expression for the numerator. Now we need to expand. So this will multiply this, and the same time multiply this. And that will give us this, and this will cancel out. And that will give us this expression 12x squared h plus 12x h squared plus 2h. Then we also simplify the numerator here to obtain this. So we factor the numerator so that we can cancel out. Now, as h is approaching 0, we can substitute h equals 0, and that will give us this expression. So when we simplify further, we split the denominator. We share the denominator for the numerators, we get 3 plus 1 over 2x squared. So from the first principle, the result is this. Okay, so we'll pause here for now, and in the next video we are going to talk about the rest of the question. We'll be discussing them. So please kindly like this video if you like it. If you like it, like this video for me, and also please don't forget to subscribe. See you again in the next video.